Hello everyone and welcome to our automated spreadsheet program for Bisection method.
Today, Group 3 will guide you through the process of setting up and using our spreadsheet program to find the roots of a given function. So here are the set of values. The given initial value of A, which is 10, the given initial value of B, which is 35, the Epsilon or the allowable error, we've set it to 0.0001. The C previous, we've used the larger number, which is 999999.
So now, let's start setting up our spreadsheet. So as you can see, there are different columns. So we have iteration A, f of A, B, f of B, C, and f of C. For A, we've just plug in the number, which is the initial value of A, which is 10, and the given initial value of B is 35. In order for us to get the f of A, we've just followed the instruction, and the instructions stated here that in order to get the f of A, f of B, f of C, use the formula called group 3 function. So we've just followed here. So as you can see here, the formula here is group 3 function D8, which is the initial value of A. And also for B, we have group 3 function f of 8. Since f of 8 is, we have here the initial value of B.
In order to get the value of C, we have here D8 plus F8 divided by 2, which represents the value of A plus the value of B divided by 2 to get the value of C.
To get the value of f of C, as you've noticed, we've used the group 3 function h of 8 because it's stated in the instruction that to get the value of f of C, just use the formula called group 3 function, and you just pull in the h of 8, which represents the value of C. So here is the formula that we use for the decision making. It means that if as h8 minus 999 is lesser than or equal 0.001, which is the value of C minus the C previous 9999 is lesser than or equal the epsilon, the decision making would mark as stop. If f of C is equal 0, then the decision will also shows stop. If f of C is lesser than 0, then the decision will shows replace A with C. If f of C is greater than 0, then the decision will show replace B with C. And also, in order for us to know if the initial value of A or the initial value of B would be invalid, would be valid or invalid, we've just used the formula that it means that the value of A times the value of B is greater than 0, then the decision would mark as invalid choice of A and B.
As you can see in the iteration number 1, I've set the C prime into the largest number. But in the iteration number 2, I've set the C prime into the value of C in the iteration number 1, which is belong to h of 8. And what I'm going to do is just to drag it down so that we can be able, or we can know when to stop the program. So as you can see here, the decision have shown the stop. So it is when you stop. You must stop because the value is now get.
To visualize the decision history, we'll use a line chart with the x-axis representing the iteration number and the y-axis representing the value of A, B, C, f of A, f of B, f of C, and decision. So we'll proceed here into the line chart. The color blue one represents the A. The color red one here in the bottom represents f of A. The color yellow one represents B, and the green one here, also in the bottom, represents f of B, and C, and letter C is the color orange one. So as for f of C, here it is seen in the bottom, the white one. So those are the lines that represents these, and we proceed to the here. So here is the visualization of decision making. So the yellow one here represents stop, and there is only one of it, and it is 5.6%. So the next one is replace A with C. It is a pink one. There is 6 of it, and it is 33.3%. So the next is the blue one. Replace B with C. There are 11 of it, and it is 61.1% in the pie chart. So let's see if the pie chart is right. So let's look for the yellow one, the stop. So as you can see here, there are only one stop. So which means the pie chart is right. So to make it sure if it is right, let's look for the other 2 more. So replace A with C. It is shown here in the pie chart that there are 6 of it. Let's count. And as for the replace B with C, there are 11. So let's count if it is right. So replace A with C. 1, 2, 3, 4, 5, 6. So in the pie chart, there was 6 of it. So it is right. So let's check the replace B with C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So that means that the pie chart is right.
In conclusion, our spreadsheet program for the bisection method automates the process of finding roots of a given function.